More money, more problems. Let's go ahead and do some more problems so we can get some more money. All right, so what is the derivative of y? Well, that would be 1, then times y prime, so this is going to be y prime, plus the derivative of sine y, which is going to be the chain rule, where we take the derivative of this, we get cosine of y, but then you have to multiply this by y prime, equals, derivative of 1 is 0, derivative of a minus x is minus 1. All right, so 0 minus 1, I'm just going to rewrite this as a negative 1. So now I'm going to pull out the y prime, and I have a 1 plus cosine y, and that's equal to negative 1. Now I'm going to divide by 1 plus cosine y. You don't really need those parentheses, but it's nice. So we get a y prime, or we could say dy dx, doesn't matter. Same thing. Dy dx is equal to negative 1 over 1 plus cosine y. All right. Now these become a little bit trickier where it says, like, prove that it's equal to this. And sometimes we get lucky and it looks exactly the same. Other times we have to do some algebra to kind of manipulate it to look like what I'm supposed to get. All right, let's take the derivative. So we see that this is the product rule. So the derivative of the first is 1 times y squared plus the derivative of the second, which is 2y times y prime, times the first, so times x. All right, now we got to do the product rule again. So the derivative of, and I'm going to put parentheses on this because I'm not going to deal with a negative x cubed. I'm just going to do product rule with this. Okay, derivative of x cubed is a 3x squared, okay, times the second, which is y, plus the derivative of the second, which is y prime, times x cubed. And that's going to be equal to 0, right? Derivative of 6 is 0. All right, let's go ahead and clean this up a little bit. We get y squared plus 2y y prime x minus 3x squared y. And then don't forget to distribute your negative to this one here. So you get a minus y prime x cubed equals 0. Okay, let's get everything without a y prime on the other side. So we'll have minus y squared. And what else? And adding a 3x squared y. Okay, so this disappears, and we are left with a 2y y prime x minus y prime x cubed is equal to, oh, don't forget to subtract my y squared over here, right? I have to do this and that. So that's going to give me my 3x squared y minus y squared. All right, give me a second to erase the above and then we'll start working on more. All right, I erased that work and then I just rewrote this bottom part right up at the top, so I'm just giving myself some more space. Okay, next step here is to pull out a y prime. So that's going to give me a 2yx minus x cubed equals 3x squared y minus y squared. Now I'm going to divide by a 2xy minus x cubed, 2xy minus x cubed. This cancels, and we're left with an answer of y prime, or dy dx, equals 3x squared y minus y squared, all over 2xy minus x cubed. And take a look at this, folks. It is a perfect match. We don't have to manipulate anything. So we're happy. All right, you might want to pause this video and try A on your own, and then we'll tackle B together. But let's see if you get the right answer of A on your own. All right, I'm going to go through this problem. So we're going to be taking the derivative of x squared is a 2x plus 2 plus 4y cubed y prime plus 4, that's derivative of 4y, and then don't forget to put the y prime equals 0. Let's subtract a 2x and a 2, so minus 2x minus 2 So we're left with a 4y cubed y prime plus 4y prime equals negative 2x minus 2. Pull out a y prime, and I'm left with a 4y cubed plus 4 equals negative 2x minus 2. Divide by 4y cubed plus 4. Divide by 4y cubed plus 4. Cancels, cancels. So I'm left with a y prime is equal to a negative 2x minus 2 over 4y cubed plus 4. Now you might see here that this does not match what we want, but we can factor and simplify and we see that we will have a match. So I'm going to pull out a negative 2 in the numerator, and then I'll have an x plus 1. And then I'm going to pull out a 4 in the denominator, and I will have a y cubed plus 1. Okay, well in this case I can divide both of these by 2. So what is negative 2 divided by 2? Well, that becomes a negative 1. And what's 4 divided by 2? That becomes a 2. And now we do have an exact match. Awesome. Let's go ahead and now let's talk about B. Okay, B is asking for an equation, and we always need a slope and a point. Well, look at this. We have a point, so we're good to go on that, but what is the slope? Well, we just found the derivative, and I don't think I've been emphasizing this enough. Implicit differentiation is the same thing as taking the derivative and finding the slope. So we're just going to find our slope by plugging in our x value of negative 2 everywhere that we see an x. Okay, so this is going to be negative 2 plus 1 divided by 2. Now we have a y. Well, guess what? We have a y right here. So no big deal. We can take that 1 because we have a y value right there. So that's going to be 1 cubed plus 1. So we get y prime equals a negative 1 over 2 times 2, because 1 cubed is 1 plus 1 is 2. So this is going to give me a 1/4. So that's my slope. All right, so what's my final answer? Well, it's going to be y minus y1, so that's going to be 1, equals a slope of 1/4, and then x minus minus 2, or x plus 2. And that is the equation of the tangent line at that point for this function right here, which is written implicitly and not explicitly like we're used to. All right, here's another problem. So we've got 2x plus the derivative of the first, which is 1, times the second, plus the derivative of the second times the first, plus 2y, y prime equals 0. Let's subtract 2x from both sides. And let's subtract a y while we're at it. Okay, that disappears, that disappears. I'm left with a y prime x plus 2y y prime equals negative 2x minus y. Pull out a y prime, and I'm left with x plus 2y. Divide by the x plus 2y. And I've got my final answer of y prime, or dy dx, equals negative 2x minus y over x plus 2y. Are these getting easier? I'm hoping that they are. All right, here's the last question that we're going to tackle here. Write an equation for the line tangent to the curve at negative 1, 1. Well, we have to first prove that this is in fact the derivative, and then we have to find the slope and then use our point to write the equation. So let's do that. Let's confirm that this is in fact true, although it is nice that they gave it to us. We get a 3y squared y prime minus parentheses derivative of the first is 1 times the second plus the derivative of the second, which is y prime, times the first equals 0. Let's go ahead and do distributive property real quickly. And that's going to give us minus y, y prime x. Okay, equals 0. Get that y on the other side. So I'm left with 3y squared y prime minus y prime x is equal to y. Pull out a y prime. I get 3y squared minus x equals y. Divide by 3y squared minus x. And we do in fact get y prime is equal to, this disappears, that's why I'm just y prime, y over 3y squared minus x. Excellent, we have confirmed it. So now let's write the equation for the tangent line at the curve. So let's find our slope by plugging in. My y value is 1, so I plug in 1 here, over 3 times 1 squared minus, what's my x? Negative 1. So my slope is equal to a 1 divided by 3 plus 1 is 1/4 again. Let me make sure that's right. 3 minus 1. Yep, because this whole thing becomes a plus 1 right here, right? All right, so my final answer is going to be y minus, okay, go back to my point right up here. Y minus 1 equals 1/4, and then an x plus 1. Awesome. Thanks for doing that with me, folks.